So this is the first sequence of our lessons of how to use Python plotting methods for data exploration and visualization. In this particular sequence, we're going to focus on univariate plot types and a little bit talk about how you use Python methods for plotting. But we're really going to focus on those univariate plot types. So we've already talked about this automobile price data set and how we clean it. So I'm not going to dwell on that again. I'll just run that and load it, and we'll just look at the head of the data frame. And again, by now this should be somewhat familiar to you. We have this data set with 120 or 195 automobiles once you clean the missing values out, and various attributes of the automobile. And what we're interested in is understanding how we can model the price of the automobile. Which of these many variables tell us something interesting about price, and how do these many variables or features relate to price? But initially, we're going to look at just univariate plot types. So things like bar plots, histograms, box plots, kernel density estimation plots, and violin plots. We'll pick up 2D plots, two variable plots, in the next sequence. So let's talk about bar plots. So the first thing you have to do in Python to compute a bar plot is to compute the counts. So from my pandas data frame of auto underbar prices, I just want, say, the make, and we'll look at the make as manufacturer, and we'll just get the vector of counts. And there you have it by manufacturer. Notice the list is ordered from the most frequent to the least frequent. And since we haven't looked at a Python plot, I'm just going to give you a few highlights. So first off, if you're working in a Jupyter notebook, make sure you have this, what's called an IPython magic command, which is matplotlib inline. If you don't have that, and notice there's a % sign there, which denotes it as a magic command. If you don't have that, it's basically an environment variable that tells the Jupyter notebook or the IPython you're using in Jupyter to display the plot inline after the code, which is what you would think should be the default, but it actually isn't. So we're going to import matplotlib.pyplot as plot. We're going to define a figure with a figure size, matplotlib figure. We're going to define an axis on that figure. So it's a set of axes. And we just have one in this case. And we get count.plots.bar on that axis. And we can give it, so then we can use methods on axis like the title, the X label, the Y label. So that's kind of the basic recipe for making a simple Python plot using matplotlib. Not too hard. A few steps. All right. And here's our result. So we have the make of the automobile on this x-axis. You see going from, and then the number of autos on the y-axis. And because our counts were ordered, this bar plot is nicely ordered. And generally, when you're doing a bar plot, it's good to have some order, whether it's from most frequent to least or the other way around. Because if you just had these randomly here, you'd have to really search like, okay, maybe the first one and the second one would be obvious, but could you really tell that there's a few more, maybe one more, the same number, it looks like, maybe of Mazdas, Mitsubishis, and Hondas here, and then the next most frequent being Volkswagens and, et cetera. So ordering it really helps you and your audience, if you're presenting this to your colleagues or something like that, understand what are the most common and least common. So that's the whole point of a bar plot, is just to look at frequency. So another related plot is histogram. And a histogram is like, now a bar plot was for categorical variables. A car is made by Toyota or it's made by some other manufacturer like Nissan or Mazda. It is not made by 8 different manufacturers, or at least the name badge on it doesn't have 8 different names on it. So again, following that same recipe, and this time let's look at engine sizes. So I've got auto prices. I'm selecting, using the square bracket operator, just engine sizes. Then I've got plot.hist on my axis. And again, just title, X label, Y label. So it's the same recipe I just showed you. But the histogram is a little different because engine size is a numeric. It's a continuous variable. And so we've binned it, and we're using just the default bin size. You can specify bin widths and things like that, but for now we're not doing that. So we can see that the most frequent auto engine size seems to fall around 100. These are in cubic inches. And there's a few cars with really large engine sizes out beyond 300, and there's some really, maybe I think that's around 80, probably less than 80 cubic inches. There's just a few cars, again, with very small engine sizes. And it's a somewhat asymmetric distribution. So we've learned a lot just by looking at the histogram of these auto engine sizes about the shape of the distribution, the dispersion, the fact that we have these sort of extreme cases of some cars with really large engines and some cars with really small engines, and the majority of cars tend to be toward the smaller end. So another way to look at this sort of distributional information is with a box plot. But now there's no point, or very little point, in just using a single box plot that's the same information that you can get from a histogram. The histogram will almost invariably give you a little more detail, but there's something else we can do. Again, following that same recipe of using the matplotlib.pyplot plot methods, I'm going to subselect now engine size and fuel type. So you see I have another column selected, and I'm going to box plot, and then I've got this by argument by fuel type on those axes. So basically I'm going to do a group by fuel type. Okay, let me run this. And you can see I've got fuel type on the x-axis and engine size on this y or vertical axis. And I have diesel and gas cars. And so it looks like gas cars have a wider range of engine sizes, and you can see all those cars with the really big engines out there, beyond say 200 and even 300 cubic inches were all gas cars. Those cars with really tiny engines were all gas cars. Diesel cars tend to be in a smaller range. So you see the advantage of a box plot like this. And you could do this with many categories of data, and we'll be doing that as we go through this course. You can quickly, by eye, compare and say, yeah, diesel cars have a tighter grouping than gas cars. Their median tends to be a little larger engine size, but there's a lot of, but the interquartile range here overlaps substantially. So there's not really probably a huge significant difference. It's just the range of gas cars is much wider. So an alternative to a histogram is a kernel density plot. And when we're doing kernel density plot, I'm going to use another Python package that's fairly new and has really become a commonly used thing. And it's the Seaborn package. So I'm just going to import Seaborn as SNS. And you have to set up a grid to plot a Seaborn plot. So I've got sns.setStyle, and I'm just going to use the most generic grid really is called white grid. So I'm just going to do that. And I can do sns.kde for kernel density estimation plot of my engine size. See how that works? So rather than doing this is an alternative to a histogram. Let me scroll down so you guys can see that. And we have essentially the density on this vertical axis and the engine size on the horizontal axis. Very similar conclusions you would draw from this, from the histogram, that our most frequent engine size is somewhere around 100 cubic inches. In this case, the density plot's saying a little bit more. We've got a few cars with really small engines, and this set of outliers somewhere out here around 300. So it's just a different way of looking at density. And in fact, you can overlay this on a histogram as well to get two views in one. So I can do a little bit fancier plot there. So I just use the very generic. So I can mix Matplotlib and Seaborn. I just wanted to give you an example of that. So first off, I can set the figure size. Notice I just took the default figure size here. I can, again, define axes. I can create my plot, but this time I say what axes I want to do that on. And then I can give it titles and labels. Notice this plot is actually not a very good plot. If I showed this to a group of my bosses, say, or my clients, other than this hint here that this is engine size, it's like, well, okay, but what's this vertical axis? What's the title? I mean, your audience cannot interpret your plot unless you have proper labels on it. So this gives combining Matplotlib and Seaborn gives us a lot more control of that. And you see we've got a plot that's a more proper plot. So it says KDE plot of auto engine size. So we know what it is. We've got density labeled properly on the vertical axis, engine size labeled properly on the horizontal axis. So there's one other plot we can use for getting, pardon me, for looking at densities. And it's similar to the box plot, and it's a newer plot type. Violin plots have only existed for maybe a few decades. Box plots go way back to work of Tukey in the early 1960s, so they've been around for more than half a century. And there's certain things about violin plots that are more attractive. And so let me just, the recipe here is the same as what you just saw using Seaborn. So let me just run it and we'll cut to the chase. So I've divided it. You see I did, my X was fuel type, my Y was engine size. And so I have gas engines and diesel engines. Recall that we looked at box plots of this before with the smaller range of diesel engines and the wider range of gas engines. But now the KDE, the kernel density estimate, defines this shape. And you can see it does kind of look, some of these do kind of look like a violin with it. Not always, but kind of. So that's where they got their name. And they're giving you the interquartile range, the median with the white dot, and the whiskers that you would see on a box plot in here just for free. So in some ways, the way the Seaborn package does this combines the best of what you learn from a box plot about interquartile range, median, whiskers, outliers, with a kernel density estimation plot. So it's a very attractive way to convey quite a bit of information about density of various variables. And again, we could subdivide this. We could do this. Right now we're just doing it by fuel type, but we could do it by any categorical variable, body style or manufacturer, or whatever it is you're interested in, to get a good look at things. So that's a quick overview of both some plot methods using Python and, more importantly, some plot types, what they're good for and how we interpret them.